despite the fact they have this fast random access, if you have an array like so, and let's just put in random numbers, whatever. If you are, pretend it's still called numbers, okay, and I say get me nums1, okay. So we know the index position is going all the way up to n-1, okay. So this retrieval is direct, okay. This is a constant time operation, okay. This is the random access, okay. And again, all you're saying is give me whatever's inside that slot, okay. Maybe we don't have knowledge that it's got number 3 in it, but this is always going to be super fast. Okay, problem with arrays though is if we then say, well, what about if we insert, let's say, I'm going to say at position 0, the number 9, okay. So I'm saying this is the index and the value. Well, we have a bit of a problem here because when I want to insert something, I want it to go in here. I don't want to replace that, okay? So insert, and that is not equal to replacement, okay? So I want to preserve everything that's already in here. There's two problems. The first problem is, well, do I actually have space? And the next problem is, well, how do I put my thing in here and still preserve the order? Okay, what's going to happen is, well, we will have to make extra space. Okay, so this is then going to have to shift along one. Okay, we've made the array bigger. Because this has to shift along one, then everything else has to shift along by 1. 1, 3, 2. Okay, so all of these have had to shift just to insert one thing at the beginning of this array. I have incurred a linear cost just moving everything 1. And again, that should be self-evident. If you need to move everything by 1, that is a linear cost. Plus then the cost to insert. And the final what we're trying to do was actually put 9 in there. Okay, so everything has shifted. And this is one of the consequences of arrays. They're not so flexible in that regard. List, on the other hand, well, if we'll take a smaller part of this list, 1, 4, it doesn't really matter, that can keep going on. If we repeat the same operation, except we can say we want to insert at the head, well, we already know this is just going to be super fast because we have our head and tail pointers already, and we can take advantage of them and then simply say, well, okay, this doesn't need to go here anymore. This can instead go to 9, and then 9 will point there. Okay, so then we can update that reference. Okay, and again, nothing else had to change. So this, as we discovered earlier on, at least in this case, when we're putting at the beginning, had a constant cost. Okay, so there are these hidden costs with arrays as well. So it's really about finding the right situation in which to use the appropriate data structure.